pour water in each other.
I said completely. If you're all
Water
wearing.
makes other things.
I'm so glad I have this on recording, just in case.
Hey, you gotta tell me I get it. So you gotta do it.
Fight! I'm sorry. I didn't eat breakfast and it made me kind of weird. Angle of elevation and depression. So elevation is when your eyeballs are going up. Depression is when you're going, your eyeballs, not your soul and not your heart, your eyeballs. The only thing in here that can be depressed are your eyeballs. Okay? Depression is looking down. Many real-world problems that involve looking up at an object can be described in the terms of angle of elevation. Okay, we just said that. So this angle, this elevation, is the distance between whatever you're looking at, that horizontal line where JoJo was looking at the tape, where that line is, and whatever he looks up at, that is the angle of elevation, whatever is horizontal and above. Okay? The angle of depression is whatever is horizontal and looking down. Like Madeline. Didn't you say you looked at justification? You looked at the blue A normally, and then, so this was normal, and then you look down, right? So everything between here is her angle of depression, because this was horizontal. Everything down is depression. What's everything up? Elevation. When an observer is looking down, the angle of depression is the angle between the observer's line of sight and the horizontal line. What I just said. Here you go. This right here. That's angle of depression. This is angle of elevation. Angle of elevation and angle of depression are always congruent. Because just like our picture, draw this picture. Here was Julia. Whoops, that's supposed to be straight. Here's Julia. Her eyeball. These are her eyeballs right here. Okay, eyeballs, eyelashes.
I don't even know what that drawing is supposed to be.
Those are her eyeballs.
Where?
Okay, these are Julia's eyeballs. Don't make fun of her eyeballs.
I didn't know there were.
Okay, here's, oh, you just wait, Ivy. I've even drawn you. Here's Ivy. Oh, I can't be mean. I don't want to be. Okay, so, okay, here's Ivy. I'm not going to be mean, Ivy. I'm just going to give you 700 eyelashes. So much that they look like they're clumped. You got that clump mascara going on. Not in real life, just in my picture. And if Ivy's eyes are looking up, this is the angle of what? Elevation. Elevator goes up. Julia's eyeballs are looking down. I'm going to connect these because y'all know how my drawing is. Julia's eyeballs are looking down, so right here is the angle of depression. These are alternate interior angles, so they are congruent. I'm glad we have people absent today so we can redo our scene of eyeballs. How old are you, Kira? Oh no, can't drive an Alabaster anymore. Example, the angle of elevation from point A to the top of the hill. So this is horizontal. Elevation is because it's going up, is 49. If point A is 400 feet from the base of the hill, how high is the hill? You still have to use trig. Okay, this is just adding on. So we're still going to use our hippie or your Indian, SOHCAHTOA. Okay, so if I'm using 49, what is 400 in regards to it? Adjacent. And what is over here? Opposite. So what hippie do I have to use? Let's come up with some hippie names. What's the name for a tangent? Tommy Chong. That kind of sounds Chinese.
That's a real person.
Oh, okay. Okay, so we're going to have to use tangent, but we already know what the angle is, so that's 49. Opposite, we don't know, that's our x. Do we know our adjacent? Which is? 400. Now to solve for x, multiply both sides by 400. What's 400 tangent of 49?
460.1
What?
degrees.
No.
Feet.
Feet.
Yes.
Feet. Okay, number 2. So the hill is 460.1 feet tall. Find the angle of elevation of the sun. So elevation's going up. When a 12.5 meter tall telephone pole casts an 18 meter long shadow. Period. I thought there was another word. Okay, so here's our telephone pole. Here's our pole. How do I know it's a pole? How do I know that one's the pole? Because the pole is what? Straight. We wouldn't be talking about a pole if it was like... Okay, 12.5 meter telephone pole. Cast a shadow. Shadows go down. Okay, so here's this one, and then obviously it's going to be a 90-degree angle because everything in trig has to be. Horizontal, and we are finding the angle of elevation. So how do I know I'm not finding this angle? Because that'd be depression. So I know that I'm finding this one. Now, find the angle of elevation because it's going up, so that's how I know it's this one. When a 12.5 meter telephone tall pole casts an 18 meter long shadow, because shadows are on the ground. So find x. Well, what do you know? What's 12.5 in regards to x? Opposite, and then this is adjacent, so we're going to use Tommy Chong again, or whatever his name was. Tangent of x equals opposite over adjacent. Now remember, when you have to break your trig function in x, whenever you break a trig function in x, what do? What happens to your trig function? Inverse. So if I'm solving for x, tangent becomes inverse, and we solve for 12.5 over 18. So x is equal to 34.7, 34.8. What is that? What am I talking about? Degrees. So the angle of elevation of the sun is 34.8. Okay, flip to the back. I want you all to work on these next 3 in your groups, and then we'll come back together and check them.